Myself Padmaja, Associate Professor, Department of CSE, Institute of Aeronautical Engineering, Hyderabad. Now, today we are going to discuss about the basics of pointer concepts, followed by the relationship of pointer with arrays, with functions, with strings, and so on. And let us solve a number of problems using pointers. So, let us start with the basics of pointers. Now, what do you mean by a pointer variable? Now, pointer variables are special types of variables which are used to store the address of another variable. Now, representation of pointers, if you talk about, pointers are represented by an indirection operator star. So, a normal variable is used to store data, whereas a pointer variable is used to store the address of another variable. Now, if you are using pointers, then processing will be faster because we are directly dealing with the memory addresses. And generally, the applications of pointers are in low-level programming, like in compilers, in operating systems, in loaders, linkers, different text editors, and so on. So whenever you want to do any low-level disk programming, then it is better to go for pointer programming because we directly deal with the hardware addresses. Now, how to declare a pointer and then how to work with a pointer. So, if you want to declare a pointer and in that address, a pointer is going to store an address, and in that address, if you are going to store an integer, then you need to declare an integer pointer. Suppose you are storing the address of a character where some character is stored, then you need to declare a character pointer. Similarly, if you are storing the address of a float, then you need to declare a float pointer. So, what is the type of pointer you are going to declare? That depends on the type of value whose address your pointer variable is going to store. So, basically there are two types of pointer. One is called generalized pointer, other one is called specialized pointer. Now, in your generalized pointer is also known as your voidic pointer or generic pointer. Void pointer or generic pointer or generalized pointer is a pointer which has a void address, You can always convert a generic pointer or a void pointer into a specialized pointer. But a specialized pointer always contains the address of any specialized variable. For example, if you want to store the address of an integer, declare one integer pointer. If you want to store the address of a character, then declare a character pointer. So these are called the specialized pointers. So which is dealing with integers, characters, float, and so on. Now here I have declared one character, one integer C, and one integer pointer, your star PC. So C is a normal variable where PC is a pointer variable. The differentiation is with the help of the indirection operator star. So C is going to store a value because it is a normal variable. So it is given over here C is equal to 5. Now the pointer now contains the address of this integer variable. So here C is an integer in memory which contains a value 5 inside it and which will have some address. Suppose the address is 1000. So this address we are going to store in your pointer PC which contains 1000. That means indirectly this pointer points to the value 5 only. So you can see here PC is equal to ampersand of C. If you write like this, that means this pointer contains the address of the integer variable. Now let us go for what are the different ways of we can declare the pointers, and these pointers can be used for not only the basic data types, you can go for also the derived data types, for functions, for your arrays and strings and so on. So here in the first three examples are for basic data types. So here we have declared one integer pointer int star ptr1. Here second one is a float star ptr2 is a float pointer, and the third one is a character pointer. For all the basic data types, you can declare a pointer variable and you can store their addresses. Similarly, if you want to store the address of an integer, so address of an array. So what is an array? An array is a collection of homogeneous data types. Suppose we have an array of integers, we have an array of characters, we have an array of floating point values. So for that array, if you want to store the address of that array in a pointer, then you can declare like this: integer star a of 5. So it is an array of 5 integer pointers. Okay. Otherwise, suppose you will just declare an array integer a of 5 is there, which contains some values 1, 2, 3, 4, 5 like this. And you want to store its address. So you can declare an integer pointer because the array is an integer array here. So you need to declare an integer pointer. And you can do p is equal to ampersand a of 0. You can write, or you can write p is equal to a. So you can store the address of the array into a pointer, or both are same. So here it is storing the starting address of this array into this pointer. Here also it is storing the starting address. A of 0 is the first element in the array. So whose address will be stored into this pointer. Now this example is an array of pointers. In array of pointers, instead of storing the values, the array itself contains 5 integer address. So int star a of 5 is nothing but it is an array of 5 integer pointers. That means this array contains 5 addresses. This is a of 5. So the 0, 1, 2, 3, 4. It contains 5 addresses. Suppose 1000, 2000, some 5000, 7000, some 9000. So each one is an address. So it contains 5 addresses of 5 different variables. Okay. So this is an array of pointer example. Next example is called your function pointer. Suppose there is a function and we want to store the starting address of the function. Then how will you declare? So every function will follow certain type, certain category, like with argument, with return type, with argument, no return type. So it follows 4 categories or 4 ways are there to write a function. So which type of function you are using, and for that function's address you need to declare. For the category of function what you are using, if you want to store its address, then you need to declare similar kind of a function pointer. So you can see over here, int star f is a function pointer which will store the address of a function, and that function takes no argument but returns an integer. So based on this category, you can write down different types of function pointers. Now, for example, if I am writing integer star p, comma int. Now, if you declare a function pointer like this, then what is the meaning it conveys? It stores the address of a function, no doubt. But what is the type of function? Whose address it is storing? It is storing the address of a function which takes 2 integer arguments and also returns an integer. So it indicates in that manner. Suppose I am writing void star fp, comma int, comma char. If I am writing like this, then this is also called the declaration of a function pointer, where it takes 2 arguments. One is integer type, one is character type, and it returns nothing. So this is the category of function whose address is there in this function pointer. So this is the example of function pointer declaration. Now let us go for a pointer to an array. Suppose we have an array containing some values 10, 280 something, and this array is of size 3 and its address is there in a pointer. So this PTR contains the 1000, which is nothing but the address of the array. Then this is called a pointer to an array. So here int star p of 3 is nothing but p is a pointer to an integer array whose size is 3. So that array is not having a name. It may have a name, it may not have a name. So directly if you want to, if you are storing the address of the array, then without having a name of the array also, you can always access the elements of the array and you can do the array operations through pointer. So this concept is called pointer to an array. Next concept is called a constant pointer. So constant pointer means the pointer which contains a fixed address which do not change. So here you can see that int star constant p. That means p is a constant pointer always pointing to the same address. So which always points to the same location where you do not want to change the address of the pointer, then it is called a constant pointer. Normally, pointer variables are changeable. So that means the same pointer variable, in the same pointer variable, you can store different addresses. So now that's why it is called a pointer variable. But if you want to make it fixed, you can declare a constant pointer which will always contain the same address and it will point to the same location. Next is called pointer to a constant integer. Okay, so integer or character, any constant value is there. If you want to point to a constant integer, that means the value will not change, it is fixed, then you can write like this: constant int star p. So here p is a pointer pointing to a constant integer. That means there is an integer value, suppose it contains 10 and the value won't change, it is a constant value whose address is suppose 1000 and this pointer p contains 1000 which is pointing to this constant. So you understand the difference between a constant pointer and a pointer to a constant. Okay, pointer to a constant means the value is constant. Okay, constant pointer means the address of the pointer is constant always. That means it always points to the same location. Okay, next example is called your generic pointer declaration. Now, the generic pointer or void pointer are nothing but the generalized pointers which has no type. So, if you will declare a generic pointer, then that pointer can be converted into any specialized type to store the address of different types of variables. So, if you want to store the address of an integer, it works as an integer pointer. If you are storing the address of a character, then it works as a character pointer and so on. So, the generic pointers requires less memory than your specialized pointer. Suppose if you want 3 different types of pointer, one is integer pointer, one is character pointer, one is float pointer, then you have to declare 3 types of pointers separately, specialized pointers you have to declare. So each pointer occupies some memory. But if you are, instead of declaring 3 specialized pointers, if you are declaring one generalized pointer or generic pointer, and if you are converting by doing explicit typecasting, if you are converting into specific type, so void to integer or void type to character type or float type, then the memory requirement for that pointer will be less. Okay, so in that way, the generic pointers are helpful. You declare a generic pointer and convert into any type based on the need of the application. Now, let us move on to the different types of pointers we use in programming. Now, depends on how many labels of indirection you want to use. The pointers are classified as single pointer, double pointer, triple pointer, multi-pointer and so on. And one very simple difference you can see that the number of stars that you write before the variable name will increase. In a single pointer, we write 1 star. In double pointer, we write 2 stars, triple pointer 3 star. It indicates that the level of indirection also increases. Okay. In a single pointer, it holds the address of any simple variable. In a double pointer, it holds the address of a single pointer. In a triple pointer, it holds the address of a double pointer and so on. So, when you will go for n number of pointers or n pointer or multi-pointer, it holds the address of the n-1th pointer's address. So, the level of indirection increases, so the complexity also increases. Though the programs using pointers are faster, but complexity level always increases. Now, let us discuss about how to declare a single pointer, double pointer and multi-pointer. So, if I am going for single pointer, then how to declare? Suppose I have a variable int x is equal to 10, comma, star p. So, what I should write? So, x is a simple variable containing the value 10. Now, p is a pointer which holds the address of a simple variable. So, suppose the address of x is 1000. So, p contains 1000. That means the pointer indirectly pointing to the value 10. So, p is equal to ampersand of x. Now, if you want to print its value, then what P will give you? P will give you always address. If you indicate with star P will give you always value. So using P, you can find out whose address, you can find out X address. What is the address of X? If you write star P, then you will get value of X. This is about single pointer. Now, let us go for double pointer. What do you mean by double pointer? Now, if you go for double pointer, suppose say int x is equal to 10 and we have a double pointer, we have a single pointer star P1 and we have a double pointer star P2. Now, what a single pointer contains? P1 holds the address of X, okay, and P2 holds, the double pointer holds the address of single pointer, that is, this is P1. So, if you see this diagram, X is equal to 10. Now, P1 contains the address of X. P1 will have an address. Every pointer variable will have some address. Suppose the pointer's address is 2000. Then, the pointer P2 contains 2000. That means it is pointing to P1. And it will have its own address, let us say 3000. So, pointer P2 indirectly also pointing to the value 10. So, here two levels of indirection. That's why it is also known as, the double pointer is also known as pointer to pointer. Okay. Now, similarly, we can work with triple pointer also. Now, let us switch on to our Dev C++ compiler and let us run these programs and check. Now, let us start with how to write a program for single pointer. Now, start with the header file #include stdio.h. How to declare a pointer? So, int main and return 0. This is the structure of the C program I have written first. Now, let us take a simple variable x is equal to 10 and declare one pointer p. Now, first you have to assign the address of x to p by writing p is equal to ampersand of x. Now, let us print the value and the address that is pointed by this pointer. So, we can write down value of x. How will you write? Value of x, how will you get? Percentile d, comma, x value. Now, what is the address? Let us write printf address of x. Address of x is always unsigned, so you can take percentile u or percentile p, you can write, okay, and you can write ampersand x. Ampersand is known to be the address operator. So, by just writing these two lines, let us save and run the program. Save it as .c file and compile and run the program. Now, you can see here the value of x is equal to 10 and the address of x in memory is, this is the address. So, it depends on your system. So, your system's address, your RAM address, you will get it. So, where x is stored, we have known it. Now, what we will do? Now, we'll print the value and address of x using pointer concept now. So, let us copy these two lines and let me write down the value is as star p. Star p gives, p is the pointer which contains address. Star p means the value in that address. And instead of writing this ampersand x, let us write only p. So, the same thing, the value of x and the address of x I want to print using pointer concepts. Now, let us run this again and you can check it in the output. The value of x is equal to 10 and the address is the same because we are using the pointer concept and it is doing the same thing. Now, if you want to do any operations on that value, you can do it through pointer also. For example, you know that star p is the value. So, what is the value? Star p means it is now referring to 10. So, I want to do star p plus 5. I want to do. Okay. So, then I want to print what is the new value. So, I can print this line again. You can do any arithmetic operation on that pointer value and you can see the result. So you can see here, earlier the value was 10, now the value is modified to 15 because you have done one addition operation. So the mathematical operations you can perform on the pointer values. So this is about the single pointer. Now let us move on to double pointer. Now for doing this program, now let me copy paste this program and let us write down here, instead of single pointer we'll go for double pointer. Now in this double pointer meaning is that which holds the address of a single pointer. The definition says that which holds the address of a single pointer. So that's why I will keep the single pointer as P1 and let me declare a double pointer as P2. Now P1 contains the address of X. Now what P2 will contain? P2 is a double pointer which contains address of P1. Now let us print the value of X only. So first two lines is the value of X and the address of X. Now the same thing we have done with single pointer. Now we will do the same thing with double pointer also. So how will you print the value and address? So let us copy paste it. Okay. Now what you will do? How will you get the value of X? You can do this by writing double star P, and the address of X you will get it by writing star P. So this is your P2, this is your P2, and this is your P1, and this is also your P1. Now let us check it whether you are getting the same results or not. So we have written the program, save it as, give a file name. Now let us run this program. Now look at this output. The value of X is equal to 10. The address is this much. So this is the normal way of doing. Using single pointer also we are getting the same thing. Using double pointer also we are getting the same thing. Only the level of indirection have changed. Okay. So this way, if you want to do some modification to the value also you can do it. For example, through double pointer, I want to change some value. So double star P2 is equal to double star P2 minus 5 I want to do. So double star P2 is nothing but it is referring to the original value of X. So if I know the address, then I can change its value. So let us check it. Now if you run this program, you can see that earlier the value of X was 10, now it is modified to 5. So you have done simple arithmetic operation on the pointers. Now this is about your double pointer. Now let us move on to triple pointer. Now before going for triple pointer, what is the definition of triple pointer first? So a triple pointer holds the address of a double pointer. It holds the address of a double pointer. So to understand this concept, let us declare one more pointer that is called triple pointer, triple star P3. And here P1 contains the address of X, P2 contains the address of P1, and let us write P3 is equal to ampersand of P2. One more level of indirection we have increased. Now print the value of X. Using single pointer, double pointer we have done. Now let us modify this to triple pointer also. So for triple pointer, here we will write one more indirection, triple star P3 will give you the value and double star P3 will give you the address. If you want to modify some value of the original variable X, you can also do it. Triple star P3 is equal to triple star P3. You can do some, suppose let us say it is minus 5 only, no problem. So you can save the program and then run it to see the output. Now let us have a look. What is the value of X? Original value of X is 10 and this is the address. Through single pointer we are displaying the same, through double pointer we are displaying the same, and through triple pointer also we are displaying the same value and address. And we are doing some arithmetic operation where we are reducing the original value of x by 5 through triple pointer. So that also you can see over here. So this is the way the basic concept of single, double and triple pointers can be used. Now let us move on to what is the relationship between pointers and arrays. Now let us move to your presentation and let us check it. Now, what is the relationship between pointer and array? This is an important concept where most of the times we use interchangeably the pointers and array accesses, and many people think that it exactly works the same way. Okay, so pointer and array accesses can be treated as acting the same, but there are certain major exceptions are there. So what are those exceptions? Let us understand. The first thing is regarding the size of operator. So you know that size of operator is used to get the size of an array or any variable. To get its size, we use size of operator. Now, the size of an array will give you what? Size of an array returns the amount of memory used by all elements of the array. Okay, suppose A is an array of size 10. That means how much memory it requires to store those 10 elements. So if I am writing integer A of 10, then if I am finding out the size of this array, how much it will give me? It will give me your each integer requires 4 bytes into 10 integers are there, totally 40 bytes is required. This is the size of operator, the usage of size of operator to get the total amount of memory requirement by the array. But if you will use the size of pointer, suppose int star p is a pointer and a is an array of size 10. Okay. Now the pointer contains the address of the array. P is equal to A means pointer contains the address of the array. That means pointer is pointing to the starting address of the array. Pointer is pointing to that array. But if you will find out what is the size of P where P is a pointer, then it will only return the amount of memory required to the pointer variable itself. Okay, it will be 4 bytes or 8 bytes depending upon your system or the configuration that you are using. So most of the cases you will get 8 bytes is the size of the pointer variable. That means the how much memory the pointer requires. So that is nothing but the amount of memory used by the pointer variable. You will get the address. You will get the answer. Okay, so this is the one of the major difference in terms of size of operator. Second is in terms of the address operator ampersand. In terms of the address operator. Now, suppose whenever we mean that ampersand of array, that means the address of array is an alias for address of array of 0. The address of the array is nothing but the starting address of the array, which is same as address of the array of 0th element or 0th index. Both are same. Okay, and it both returns the address of the first element of the array. Okay, so this is same in case of an address operator used in an array. But the address of pointer, if you will use address of pointer, returns the address of the pointer. So hope this thing will be clear. So pointer, ampersand of pointer returns the address of pointer, whereas ampersand of array, address of array returns the address of the first element in the array. So this is one of the major difference between pointer and array. Now the next difference is in terms of string literal initialization of a character array. Suppose if there is a character array is equal to ABC, where ABC is a string, that means that character array contains 4 elements, A, B, C and the null character. It contains 4 elements. Okay. Now, if you will refer to this, the same thing we can write. That means the array itself contains its own address. Array itself works as a pointer. So, in the second case, we have used a specialized pointer which points to the string ABC. That means that ABC string is again stored into a character array A, B, C and the null character, it is there. Okay, and the pointer PTR contains the address of this. Suppose 1000 is the address, it contains 1000. So, what is the difference between these two ways of declaring? Directly declaring an array contains the character, the array contains the string where individual characters are stored in individual locations, or a pointer pointing to a string. So, that string is again internally stored into a character array whose starting address is contained by this pointer. Now, declaration wise both are same. Okay, and common thing is the array name can work as a pointer which will give you the starting address, and also this pointer will give you the starting address. But still there is some difference. What is the difference? That the values B and C, the characters B and C, which is normally in this declaration, in the pointer declaration, the characters B and C, these values A, B, C are stored in read-only memory and thus unchangeable. If you want to change it, then it is not possible. But whereas in this case, the values, the characters A, B, C are changeable. That is the difference. Okay. Now, pointer variables, second difference is pointer variables can be assigned a value, whereas a array variable cannot be assigned with a value. That is the difference. Okay. So, to a pointer variable, you can assign a value also, but you cannot assign a value to an array variable. So, these are the two differences between your pointers and arrays. Now, let us understand this concept with the help of a program. Now, let us move to our Dev C++. So, the concept is regarding pointer and array. So, we'll start writing hash include stdio.h int main and return 0. So, I have completed writing this structure. Now, let us do some pointer operation. Okay. Now, let me declare one integer array of size 5, and it contains initially, it contains some 5 integers. Okay. 3, 5, some 8, 9, 2, something, some integers it contains, 5 integers. And there is an integer pointer. Okay. Int star p is equal to a. Now, what do you mean by this? P is a pointer which pointing to the address of the array, or which pointer which contains the starting address of the array. Similarly, if I'll go for star ptr of size 5 is equal to ampersand of a. Now, what is the meaning? So, star ptr means it is a pointer to an array of size 5 whose address is same as the address of a of 5. Okay. Star ptr is a pointer to an integer array whose address is same as the address of the array A. So, that means here star p and ptr both contains the address of the same array. Both contain the address of the same array. But there is a difference. Okay. What are the differences? Let us see. So, how to print those differences? So, let us print the address of array. So, let us write address of array. So, address of array is nothing but, let us write p is equal to percentile p, okay, comma, ptr is equal to percentile p. We want to print the addresses. Okay. So, how to write? Addresses are stored into the variable p and ptr. And from this statement, you know that both p and ptr both contains the address of the same array. So, let us save this program and check what is the address that you are getting. So, is it the same address held by p and ptr or not? Let us check it first. Now, you can see it over here that the address of array p is same as the address of ptr. P and ptr both contain the address of the same array A. So, it is same. Okay. Now, let us check the value by writing printf is equal to, printf is nothing but the value of array. Okay, how will you write? Your value is nothing but star p. Star p is equal to the integers we have taken. So let us take percentile d. Okay, and star ptr is equal to your percentile d. Star p comma star ptr. Now here I am trying to print the values that is pointed to by both the pointers. Now let us check it. Now in the first one, you have seen that both P and PTR contains the same address. But if you are printing the value, you can see that star P gives the starting value because star P contains the address of the 0th index element, which is nothing but 3 in this example. Okay, so you are getting the value at the first, that is your 0th index or the starting index is 3. But can you see over here that star PTR is not giving you a value because it is nothing but it is giving you an address only. It is not giving you a value, but it is giving you an address only. So if you want to check, let us check it by writing percentile P. So you are getting the address of, you are getting the same address. Let us check it over here. You are getting the same address because this is a pointer to a 5, pointer to an array of size 5. So what that pointer contains? That pointer contains an address but not the value. So star PTR will give you an address of the a 5-sized array but not the value. This is the difference you need to understand. Okay. Now similarly, if you want to check the size, so you can write it down that size of PTR. How much you will get? What is the size of PTR? Percentile LU you can write down and size of your star PTR. How will you get the size of PTR and size of star PTR? So you can write down size of PTR, comma, size of star PTR. Now, before printing size of PTR and size of star PTR, let us print what is the size of P and star P so that our things will be more clear. Okay. So let us write down size of P. What is the size of the pointer? And what is the size of your? So here we'll write down P and star P. After understanding this, then we'll go for size of PTR. So let me put this in comment lines and save and run the program. Now, let us have a look. So, the first line contains the address of both the pointers which are same. The second line contains the value of the starting address. The value is 3, but star PTR will give you an address, starting address, same address only it will give you. Now, what is the size of pointer? The size of P is a pointer. So, what is the size of pointer? It is 8 bytes. In this system, in this configuration, it is 8 bytes. But what is the size of star P? Star P indicates the size of the first integer. It contains the, P contains the address of that integer. In that address of one integer and in that place one integer is there. What is the size of integer? It is 4 bytes. So, we are getting 4. Okay. Now, let us check with your PTR also. So, if you check with PTR, what you will get? Now, have a look. Size of PTR. PTR is always a pointer. So, whether it is P or PTR, all the pointers are having size 8 bytes in this system. So, size of pointer is 8 bytes. So, size of pointer will not change in this case. But what is size of star PTR? What is star PTR? Star PTR is a pointer to a 5-sized array. 5-sized array. That means that array contains 5 integers. So, what is the total size that is, it is pointing to a 20 bytes area. So which is nothing but 4 into 5. 4 is the size of each integer and there are 5 slots. So 4 into 5 it is 20. So this is the difference between the pointer and array concept. So in this example, I have tried to explain you what do you mean by a pointer to an array and what do you mean by pointer to an integer array of some locations. Okay. Now let us go back to our presentation and understand what is the relationship with the functions. Now pointers as function arguments. So pointer as a function parameter is used to hold the address of the arguments passed during function call, and this kind of mechanism is called call by reference mechanism. Now when a function is called by reference, any change made to that reference variable will affect the original variable. So there are two types of parameter passing mechanisms we use in functions. One is called your pass by value or call by value and call by reference. So call by reference is a pointer mechanism where we are passing the address of the arguments instead of the values. So any change made to those arguments will affect the original arguments. Now next concept is functions returning pointer variables. So normally a function can return any value, but if you want to return the address, it is also possible. So that concept is called a function can also return a pointer to the calling function. Similarly, we can write down pointers to functions also. Now it is possible to declare a pointer to a function which can be used as an argument in another function also. For example, you can see here sum is a function. What type of function it is? It takes two integer arguments and returns an integer. So whenever you want to keep the address of this function into a function pointer and do the operations, then you have to declare a function pointer like this int star s, where s is a function pointer which takes two arguments and returns an integer. Now here, how to assign the address? So the assignment of the address of the function is done through like this, s is equal to sum. That means the address of the function is assigned to the function pointer s. Okay. So this way you can declare. So let us go for one example here. Now s is a normal variable. Okay. Now here we have declared one function pointer for storing the address of this function sum. Now fp contains the address of sum, and we are doing the function calling by passing two arguments 10 and 15. So we are writing star fp 10, 15. So 10 and 15 are the two arguments and we are calling the function through its address. Okay. Now this function returns an integer value that will be stored into the variable s. Okay. Now, so because the function pointers knows the address of the sum, so the function call jumps to the sum function. So the value of x is here 10, the value of y is here 15. Now you are passing these two arguments. It is finding out 10 plus 15, 25. It is returning 25, and the return value will be stored into the variable s, and then we are displaying the sum. So this is called pointer to function argument. Similarly, we can write down an array of function pointers also. How to write an array of function pointers? Suppose sum is a function and sub is a function. So both are with argument with return type. Okay. So we have to declare two function pointers, which one will hold the address of sum and the other one will hold the address of subtraction function. So we have declared an array of function pointers. So fp of 0 contains the address of sum, fp of 1 contains the address of sub. Now while declaring array of function pointers, we have used the same structures star fp of 2 because we need to store two functions addresses. So fp of 0 will contain the address of sum, fp of 1 contain the address of sub. But here one thing you have to remember, if you are declaring array of function pointers, then all the functions whose address you are going to store in pointers must be of same type. Then it is easy to go for array of function pointers. Okay, so both are taking two arguments returning integers. So both are similar type. So array of function pointers works over here. Now, if you are calling the sub function, how will you call? Star fp of 0, which contains the address of some function by passing the arguments 10 and 15. Similarly, star fp of 1 contains the address of subtraction function. So you are calling that and you are passing the argument 10 and 15. So the control jumps to sum function. It is returning the value of 10 plus 15, which is nothing but 25, and the return value is stored into S1. Similarly, when you call the second function, the control jumps to the subtraction function. It is doing 10 minus 15, that is minus 5, and the return value is stored into the variable S2. And then you are displaying the return values of sum function and subtraction function. So, thank you so much. In today's video, we have understood the basics of pointer concept, followed by the relationships of your pointers with arrays, with functions, with strings, and so on. Thank you so much.
Like, share and subscribe. Hit the bell icon for more updates.